Hello guys, welcome back. How are you doing? The answer I am expecting is you are doing good. Okay, so in this part I will be discussing about the different preparation techniques of your amines. So basically how you can generally prepare amine from your alcohol, right? So to know this you have to go for the next part. So why to waste our time? Let's start with the part. Preparation techniques of amines. So what are the different general methods of preparations of amines? So the first important thing which you have to understand is alkylation of NH2 with alkyl halides or alcohols. So if I have an alkyl halide CS3I, right, if I just react it with ammonia, I will be getting your amine CS3NH2. So a given alkyl halide can be converted into your amine and I will be getting obviously HI here. So this reaction is called Hofmann's method. So Hofmann's method involves conversion of your alkyl halides or your alcohols into amines. So the first important point I can understand here is that yes, I can prepare amines from your alkyl halides. So exhaustive methylation, that means if I have a 1 degree amine, and in the presence of your alkyl halide you can convert into a 2 degree amine. This 2 degree amine in the presence of your alkyl halide converts into a 3 degree amine. A 3 degree amine in presence of your alkyl halide converts into your 4 degree ammonium salt. So what is happening here? This is exhaustive methylation. That means a methyl group is being added and added. So it is finally converted into your 4 degree ammonium salt from your 1 degree amine. So for the whole process of Hofmann's method, your aryl halides show low reactivity for the reaction. So next you can see now second thing from alcohol. So your alcohol in presence of your ammonia, in presence of Al2O3, you will get ethylamine, and this ethylamine in presence of ethyl alcohol, it gives diethylamine. In presence of C2H5OH, you will get triethylamine. Again it's the same process, that is nothing but this is exhaustive methylation. So exhaustive methylation involves conversion of your 1 degree ethylamine to 2 degree into your 3 degree. So this method yields a mixture of 1 degree, 2 degree, 3 degree and 4 degree salts. And if you are getting these different types of amines, how to separate them? They can be separated by Hinsberg method. So this is another important point, right? So you can separate 1 degree, 2 degree, 3 degree amine from or by the means of your Hinsberg method. So Hofmann method and fractional distillation. However, not only Hinsberg method, you have your Hofmann method and fractional distillation. So another important point you have to understand here is that your 1 degree amines can be prepared in a good yield by using excess of ammonia, right? So if you just want a 1 degree amine, so this amine, so how to prepare that? Just use excess ammonia and in presence of ZnCl2 at 300 degrees centigrade, you will get RnH2. Next important technique is from your nitroalkanes. So 3 from nitroalkanes. So you have a nitroalkane, just reduce your nitroalkane in presence of a reducing agent like tin or HCl, or another reducing agent like your nickel, hydrogen in presence of nickel and lithium aluminium hydride, you will get ethylamine. So not only that, this is applicable for your aryl nitro compounds. You can reduce in presence of tin and you will get aniline. So next is your Mendes reaction of your alkyl cyanides. That means with the help of alkyl cyanides, I can convert that into your 1 degree amine. And how I can convert? I can use sodium in presence of ethyl alcohol, right? So in presence of a reducing agent like lithium aluminum hydride, I can convert this into amine, right? So the important technique here is that your cyano group is converted into your CH2NH2, right? That means initially I have 2 carbons, finally also have 2 carbons, right? So remember this important thing, that is the reagents which you are using. So sodium in presence of ethyl alcohol, lithium aluminum hydride is actually the reagent used. So reduction of alkyl isocyanides can also takes place. Now the third thing is cyanide or alkyl cyanide. The fourth thing is your isocyanide. So if you have isocyanide, that can be converted into a secondary amine. So you can see here that if you have an isocyanide, it converts into a 2 degree amine. Next, by reduction of amides. So next 5 is your amides. So how to convert an amide into amine? Just reduce in presence of lithium aluminum hydride. Now you can see here I have cyclohexanone, which is a ketone. How to convert this into amine is a challenging task. The first important thing which you have to do is that you actually convert this into your amide, and once you convert into amide, just reduce it, you will get amine. So Hoffman bromide reaction. So you have an amide. This is again an important technique of preparation of your amines. What happens is that you have an amide and amides in presence of bromine and your basic solution of potassium hydroxide, you will get amine, and not only that, KBr, K2CO3 and 2H2O. What is very important in this whole process is that there is reduction of 1 carbon. Here you have 2 carbons, here you have 1 carbon. That means it's a step down process. So you can do the same thing if you have an aryl amide. Aryl amide is converted into C6H5NH2. So here also there is loss of 1 carbon. So 1 carbon is removed in the whole process. So this is another technique from your amides. Next, your Gabriel thalamide reaction. So in Gabriel thalamide reaction, your potassium thalamide is formed after reaction of thalamide with KOH. On heating with your alkyl halide, it gives N-alkyl thalamide. This on hydrolysis with 20% hydrochloric acid under pressure gives a 1 degree amine. So in the whole process, one important thing is that you have to understand what is alkyl thalamide. So this is an alkyl thalamide, right? This on hydrolysis in presence of 20% HCl, you will get phthalic acid and NH2. So can I say now the Gabriel thalamide reaction is also a preparation technique for your acid, which is a phthalic acid? Yes, I can say that, but also you will get a 1 degree amine. So what are the other techniques involved? The other techniques involved are by action of chloramine on Grignard reagent. So if you have a Grignard reagent, you just react it with chloramine. This is chloramine. So you will get a tertiary butylamine, right? And also you can get by decarboxylation of your amino acids. If you have a glycine, which is an amino acid, just it undergoes decarboxylation to give your methylamine. This is a very important Wood's method. Why it is important is that here also you are using isocyanate, just like we used isocyanate in the previous technique. So you are using isocyanate in presence of H2O and HCl, you will get a primary amine, and not only that, you will get formic acid. So the same thing happens when you have methyl isocyanide in presence of KOH. Then you will get a primary amine. Instead of your formic acid, you will get K2CO3. This is important again, skimmed reaction. So what happens is that in skimmed reaction, you have your CS3COH acetic acid in presence of this N3H and concentrated H2SO4, you will again get an amine which is methylamine. And remember, there is carbon dioxide and nitrogen which is getting evolved. So what happens if now this amines reacts with HNO2? So this is another interesting topic. Your nitrous acid, which is a weak acid, is actually, on reaction with NaNO2 or with aqueous H2SO4 or HCl, you will get your nitrous acid. So HNO2 plus H2O, you will get H3NO2 minus, you have pKa. So in these reactions with amines, right, in the reaction with amines, nitrous acid, it actually participates in proton transfer reactions, and it is a source of nitrosylation. That means NO plus is generated, which is actually a weak electrophile. Formation of NO plus. So how NO plus is generally formed? So we have NO plus formed as in this process. How this is formed? You have HNO2 in acidic medium, which forms HNO3 plus, and after that what happens? You have H2O which is removed, and then nitrosyl cation is formed. Right. So we study the reactions of HNO2 of 1 degree and 2 degree in deep. I mean 1 degree, 2 degree and 3 degree aliphatic and aromatic amines when I discuss about the reactions, that two chemical reactions of your amines. I will be discussing in detail. So the first checkpoint. So which of the following compounds exist as your non-resolvable racemic mixture? So this is a question which actually is depending on the logic which you have to understand, right? As I already told you in one of the previous part about your chirality of your amines, right? So this is a question related to the same concept, right? So what happens is that if you have a tertiary amine, that tertiary amine has actually a chiral nature, but what happens is that because of the pyramidal inversion, your total mixture is a non-resolvable racemic mixture. It is a non-resolvable racemic mixture. So that's why the answer for this is D, because tertiary amines contains all the three alkyl groups different, giving non-resolvable mixture. Right, so answer D is correct. Next important checkpoint, the statement not correct for piperidine. So what is piperidine? Piperidine is a heterocyclic compound, right? Piperidine is a heterocyclic compound. I have discussed about this when I was actually discussing about the structures of your amines. So I discussed about your homocyclic compounds and heterocyclic compounds. So piperidine was an heterocyclic, right? So you can refer to the first or the second part related to this topic related to piperidine. So piperidine is actually a heterocyclic compound, and it is also more basic than pyridine, and it is also more basic than aniline. So hence here A, C, D are correct, B is wrong. So the statement not correct for piperidine is B.
So students, after going through the video lectures and video solutions, so you might be still having some doubts, right, related to a new theory or related to a numerical. So what you have to do is just go to our website www.askIITians.com, and on the website just select the tab Ask a Question, and on the right side of the screen you can find Ask Experts icon. So on this icon just select your category. For example, if you have a physical chemistry question, and just post your question. Likewise you can post your organic chemistry question or inorganic chemistry question, and you'll be getting the solution and answer for your question within 24 to 48 hours.
So guys, these are the different preparation techniques of amines. So in our next part
we'll be discussing about further interesting topics like physical properties of amines. Stay tuned to our sessions and stay tuned to our different e-commerce videos. We'll meet in the next part. Till then, take care. Goodbye.